Hi guys, today I just want to go over the Doppler effect, and also I want to go over the homework from last cycle. It was on wave speed calculations, and there were three questions, and these are the three answers and how to do it. So keep in mind it's all based off of this triangle here, where you have the V on the top represents wave speed, the F represents frequency in hertz, and then the lambda represents the wavelength in meters. So if they're beside each other on the bottom, you multiply. If there's one over it, to find the other one, you divide. Okay. So for the first one, to get the speed, you had to multiply frequency times hertz, and that was 5,500 meters per second. The second one, you had to find the wavelength. So you had to do some division because you had to divide the velocity by the frequency, okay? And you ended up with 0.77. And the third one, you had to find the wavelength. So you had to do another division. You had to divide the wave speed by the frequency, and you end up with 291 meters. Okay, so hopefully you got those. Make sure you check your answers. Right. Move on. All right, so the Doppler effect. So this is just one of the concepts in the waves that I want you to understand. Consider this is a little tiny bug in a pond, and he's bobbing up and down. Say this is the bug here in the middle, and these are the circle, the waves that he's making that go outward. Now notice they are concentric, which means they are all the same frequency and that they are even. Now that same bug tends to be traveling towards the right in this direction. Okay. What do you notice about this now, the new circles, the new waves? Okay, so maybe you said that you notice these waves here have a higher frequency as the ones back here. As he moves in this direction, they tend to get faster here. Okay, so if the bug moved in the new wave is generated at the new center where the bug is bobbing, and you will notice a change in frequency. The bug maintains the same frequency. The observer sees a higher frequency if towards and lower if away. So here you'll see the higher frequency, but over here you would see a lower frequency. Apparent change in the frequency is called the Doppler effect. The best way to demonstrate this is if you're listening to either a car or train that is coming towards you, you notice the change in the sound. What you're hearing is the change in the frequency as it comes towards you versus if it was going away from you. Listen. Oop, I lost it. Try that again. Okay, did everybody hear that difference? So listen again. You can hear it. Higher frequency coming in. Lower pitch as it leaves. I hope you all heard that. Higher pitch as it comes in, lower pitch as it leaves. So same kind of thing if you're listening to, say, a fire engine or a police car or a race car driving past you. Notice that it's coming in at a higher frequency as it leaves. This is how they use radar, actually. So here you have the cop car with the radar gun sending out the ongoing waves, hitting the vehicle. The vehicle sends its own waves back in the form of speed, and you can see these reflective waves show what frequency they're traveling at. Doppler's effect is used in radar waves to measure the speeds of cars. Police bounce them off moving cars. The reflected wave will be higher frequency. Depending on the frequency, the computer can calculate the speed. All right, another thing that is interesting about the Doppler effect is the appearance of color. Okay, so when a light source approaches there is an increase in its measured frequency. So that means if coming in, you're going to see more, or I should say, leaving, going out, sorry, this direction, you're going to see more red. Coming in, you're going to see more blue. So if they're looking at, I don't know, stars or things out in the universe, the ones coming in, that's going to be more of a bluer shade versus the ones going outward, more outward, are going to be more of a reddish shade. And that has to do with wavelengths again. Remember, the visible light spectrum is on the wavelengths, so that falls in line with what we talked about before. When it recedes, there is a decrease in frequency. And that's basically it. Okay. So I will leave a short worksheet about this to answer tonight. And if you have any questions, comments, concerns, feel free to email me. Thank you.